A new straddle on euro-dollar sounds like easy money on paper. You place a buy stop above price, a sell stop below price, and wait for a major economic announcement to force a breakout. But in live market conditions, spread expansion and slippage will often trigger both stop orders at the exact same millisecond before wiping out your margin. By the end of this video, you will know how to build a fully automated straddle bot in Python and MetaTrader 5 that filters out spread spikes, handles execution latency, and survives real market costs. I am not selling you a pre-packaged expert advisor or promising 90% win rates. I have spent 6 years automating trading systems across stocks, crypto, and foreign exchange, and I can tell you that straddle strategies look effortless in simple backtests, but break terribly in production. This video is for retail developers and traders who want to connect Python to MetaTrader 5, build a straddle bot line by line, and understand the unglamorous plumbing required to keep an automated script alive. Let us start by setting up our architecture. We are using Python 3 to drive the MetaTrader 5 terminal interface library. The core concept of a straddle strategy is mechanical price boundary breakout trading. We isolate a period of low volatility, such as the 30 minutes preceding a major central bank rate statement or employment report, calculate the high and low price bounds of that consolidation window, and submit 2 pending orders. If price breaks upward past our upper threshold, our buy stop order turns into a live long position. If price drops downward past our lower threshold, our sell stop order turns into a live short position. In a theoretical world, one order triggers, reaches its target profit, and we cancel the opposite order. To write this in Python, we first establish a connection to the terminal using MetaTrader 5 initialize. We verify that the terminal is connected and that algorithmic trading is enabled in the platform settings. If either check fails, the script must abort immediately rather than attempting to send unauthenticated trading commands into a void. Next, we pull historical bar data to establish our breakout range. We fetch the last 6 5-minute candles using copy rates from position. Using pandas, we take the maximum high price of those bars to define our upper breakout level, and the minimum low price to define our lower breakout level. We then add a buffer offset of 5 pips to both sides to reduce false breakout triggers. Placing the pending orders requires constructing request dictionaries for MetaTrader 5 order send. For the long leg, we set the order type to order type by stop, with the price set to our upper range plus 5 pips. For the short leg, we set the order type to order type sell stop, with the price set to our lower range minus 5 pips. We specify our stop loss distance at 10 pips, our take profit target at 20 pips, and set the lot size to 0.01 for testing. When we execute this script during calm market conditions, the terminal accepts both pending orders cleanly. We see our buy stop sitting above current price and our sell stop sitting below current price. On a visual inspection, the build looks complete. But running this code live during a high volatility news event will quickly expose why naive straddle bots lose money. Now let us look at the turn. The first mechanical point of failure is spread widening. Brokers do not maintain tight fixed spreads during economic events. Liquidity providers withdraw their ask and bid quotes seconds before major data releases. As liquidity vanishes, the bid-ask spread can widen from 0.5 pips to 15 pips in a single market tick. Because a buy-stop order triggers off the ask price and a sell-stop order triggers off the bid price, a 15-pip spread expansion inflates the quote boundary instantly. The bid drops enough to trigger your short order, while the ask rises enough to trigger your long order at the exact same time. Your bot enters 2 opposing positions at maximum spread cost, hitting stop losses on both sides before price even makes a directional move. The second silent killer is your MetaTrader 5 account execution mode. MetaTrader 5 accounts operate in either netting mode or hedging mode. In a netting account, you cannot hold simultaneous long and short positions on the same asset. If your straddle bot opens a short trade while a long trade is active, the terminal will not open a new position. Instead, it will close or reduce your existing long trade. If you write Python automation assuming a hedge account model while running on a netting account, your order logic silently breaks. When one leg triggers, the opposite pending order remains open on the server. If price later reverses, that orphaned pending order executes blindly hours later, exposing your capital to unintended market risk without any active management logic running in Python. The third point of failure is network execution latency and slippage. Sending trade requests from Python to the MetaTrader 5 terminal introduces an interprocess communication overhead. During news spikes, order book updates occur faster than your local network interface can transmit packets. By the time your order send request reaches the broker server, the price where you requested execution no longer exists. The server fills your pending order 10 pips worse than specified, destroying your risk-reward ratio before the trade even begins. To build a straddle bot that survives live conditions, we must refactor our Python code defensively. First, we add an automated account environment check before any orders are structured. We query account info margin mode. If the return mode is not retail hedging, our script logs an explicit execution error and terminates execution before submitting trades. Second, we implement a dynamic pre-trade spread filter. Before placing pending orders, our Python loop requests symbol info for EUR/dollar and calculates the current spread in pips. We define a hard maximum spread threshold of 3 pips. If the current spread exceeds this limit, the bot cancels order placement and waits for spread normalization. This prevents the script from submitting straddles during extreme liquidity vacuums. Third, we eliminate orphaned pending orders by specifying hard server-side expiration timestamps within the order request dictionary. We set type time to order time specified, and provide an expiration time stamp set to 10 minutes in the future. This guarantees that if neither breakout boundary is reached within 10 minutes, the broker server automatically purges the pending orders, regardless of whether our Python script remains connected. Finally, we build explicit one cancels the other handling inside our main execution loop. Python continuously polls positions get. As soon as the active position count for EUR/dollar transitions from 0 to 1, the script immediately extracts the ticket ID of the remaining pending order and submits an order type remove request to delete the untriggered leg within milliseconds. Here is the noble insight that most strategy vendors will never admit to you. A straddle strategy does not fail because the market refused to move. It fails because liquidity vanished at the exact moment you needed execution certainty. Slippage and spread expansion during high-impact news are not bugs in your code, they are structural realities of distributed electronic markets. You can write pristine Python code with perfect error handling, dynamic spread checks, and instant cancellation logic. But no software script can force a liquidity provider to fill your order at a price level where no market counterparty exists. A thin edge in a straddle system comes entirely from strict trade selection, not high leverage. If your backtested strategy requires sub-pip fill accuracy to remain profitable, it is not a robust system. It is a fragile illusion that will dissolve in live execution. Let us recap the 3 key takeaways from this build. First, always programmatically verify that your terminal is operating in hedge account mode and enforce hard pre-trade spread filters in Python before submitting pending orders. Second, use explicit server-side order expiration timestamps and build an active event loop to handle one cancels the other order removal immediately upon position fill. Third, factor realistic execution slippage and spread widening directly into your backtesting models before risking real capital. If you want more honest, engineering-focused automation builds without the sales hype, subscribe to the channel. In the next video, we are breaking down netting versus hedge account settings in MetaTrader 5 and showing how account execution modes quietly ruin multi-position Python strategies. This video is for educational purposes only and does not constitute financial advice. Algorithmic trading carries significant financial risk, and past performance is no guarantee of future results. This video uses an AI-generated voice.